What's up, guys? Chris here with another episode of Tech Fabric. I'm a solutions architect, network engineer, and today we're going to talk about some of the tooling in your network infrastructure. We're going to talk about how you acquire the data needed to feed into some of your network tooling, what those tools are, and why you might use them. And then we're going to show some examples of IP Fabric and some other tools that you might have in your infrastructure and our current integrations with them. So this will be a broad overview of some of the tools that you might want to use and why you're going to use them. And then we'll talk about how IP Fabric can be used for network assurance and just overall what network assurance is. There's multiple concepts when it comes to network assurance. There's pre-validation and post-validation. And we're going to unlock both of those concepts and really just talk about what tools you can use to do this type of network assurance. Let's get started. With every episode of Tech Fabric, I think it's important to discuss the current concepts and what we're going to talk about in general. So we're going to talk about your network, what's in your network, all the different devices in your network. We're going to talk about how you do collection on these devices, how you do monitoring on these devices, where you store all that information, configuring these devices, and learning new ways to access information about your network infrastructure. We're going to talk about all the different areas of your network and how do you manage those different areas of your network, whether it be a cloud environment, AWS, Azure, GCP, your LAN environment, switching infrastructure, things like that, or a complex switching infrastructure, layer 3 topology in your data center, SD-WAN, and how you're conducting those operations, cloud, handoffs and stuff like that, your wireless infrastructure, how are you using it, how are users accessing your wireless infrastructure, how is the quality of your wireless infrastructure, how is the quality of your overall network. Some of these concepts we'll talk about. How do you do the collection of information? So once you get some access to network data, right, what I want to talk about and here and stay on this topic for a second is how do you use it, how do you organize it, and what to do with it, right? So first off, what do you want to do with the network data? I think that's a question you need to answer before you start coming up with requirements about the tooling that you're going to use to get that data, right? So how do you intend to use this data? Do you want to use it for real-time monitoring, live monitoring? What do you want to do once you have access to this information? And then I think it's important to talk about how you organize that data. That data that you're extracting now, how do you want to index it, right? Do you want to stick it in a database and require people to understand a new language, or access to the data might now become difficult for some who don't know the database language that you choose? Where you store that information, I think, is extremely valuable. And yeah, just really defining all the categories of what you propose, what business intelligence are you going to be providing with this network data? Is it related to only technical people, right? Is this data that you're going to use only for your networking team to troubleshoot and have access to quicker and faster? Or is this data to be used by everybody and for other people to confirm that their network infrastructure is behaving the way they expect? Once you define some of these requirements, it helps you understand what tools you'll need, and it'll help you understand what infrastructure data is going to be most important to you. So once you start defining those requirements, I think that's just a critical thing to do before you decide what tools to use. So the big topic is network data. So let's bring it back full circle, right? The big topic is network data. We want access to it. We want access to it in an organized way, but you need to define the requirements of what you're going to do with that data. That helps drive all the different methods that are available to extract information out of your network. All right, so we talked about access to network data, how important that is, and what tools you need to decide to use to get that data, right? So let's talk about those different silos of information that the data is going to be stored in and what you're going to actually use that data for, right? So we have config backup as a bunch of text files stored in either maybe a Git repo, or you're storing raw configs in a database somehow And you want the ability to quickly search through these configs, right? So config backup, the data that you need to store there is raw text files, right? Or just raw text in general, right? So logging information, this is a standardized format of information, right? There's parsers out there, systems out there that are very proficient at sucking in logs and analyzing those logs and being able to provide resources and information that allows your infrastructure engineers and developers access to that logging information. So you need some type of system for logging, right? Now your CMDB, whatever that CMDB tool of choice is, you need to make sure that it's easily queryable. Most CMDBs are very table focused. And I think this one's a very important one to decide what is your CMDB going to be. Is it going to be like a homegrown solution that is maintained by maybe a database team and a full development team that exposes that information somehow to other people to consume it? Or is it going to be some traditional system, ServiceNow, Remedy, things like that, that house this information, right? Your IPAM systems, right? So being able to store accurate inventory of your IP address and your IP space in general, right? And this includes DNS as well, right? Being able to store that information and having a reliable system that is easily queryable, right? Both with a maybe friendly front end and a GUI interface for users to log into the system and request information or request an IP address for themselves. But you also want to make sure that it's easily usable in maybe either automations or it's just accessible to the network engineers when they need that information about what an IP address belongs to. You want to make sure that your IPAM system is easily queryable this way too, right? And this also goes hand in hand with your CMDB. Your CMDB is going to have some information from your IPAM, right? But your CMDB might be used for different business purposes, where your IPAM is only going to be related to technology folk, right? Actually using the IP address for access to the network infrastructure. And these three that kind of go hand in hand with what I just mentioned, right? So flow data is actually the information of how well is the data flowing between two of those IP addresses in your IPAM space, right? So you want to be able to track how the data between these two IP addresses is flowing. You want to be able to understand, is it being sent reliably? Are my users, does it seem like my users have consistent access to my network? And when they request information, do they have reliable service, right? And as well as for their own applications, you want to make sure that your network infrastructure, you want to be able to confirm that they are having the access that they need. So whether that's speed, whether that's defining security rules and confirming that they actually have access. Maybe you want to do it the other way too and actually confirm they don't have access to something and do some auditing. You need this, what we call flow data, right? For the information from one IP to another IP. And then these two down here definitely go hand in hand with each other, right? So there's definitely a difference between real-time monitoring and near real-time monitoring, right? So real-time monitoring definitely going to be a system that alerts you more than stores information, right? So you want this real-time monitoring tool to just, hey, something happened. Where your real near-time monitoring might be able to tell you what happened, right? And I think the two biggest things about these two different types of systems, these are going to be very unique systems. Tools in this space have been around for a while, but these are very unique tools that can do this type of things. The most traditional tools will use SNMP monitoring for real time. Newer technologies will use open telemetry data. But near real time monitoring is just going to be able to give you breadcrumbs of a starting point of where the issue might be. So you want to use these two hand in hand. So when something occurs, you want to be able to reference your near real-time tools to identify and dig into what happened, right? So let's dig into each of these different silos or buckets of information and actually what are the main uses for them, right? So we just talked about real-time, but let's stick on it, right? So real-time monitoring. I want to be informed when something has happened. As soon as it occurs, I need to know and what was affected. Most of the tools out there are very good at letting you know exactly what network device might have had an issue, right? They'll quickly alert you. They'll quickly give you the information you need. How you tie that into the rest of your tooling infrastructure is completely up to you.
But the real-time monitoring tool is really there just to tell you, hey, this device went down, or this interface flapped, or you reached some type of threshold on a certain amount of bandwidth. So real-time monitoring lets you know immediately when something occurred. So let's go on to the next one real quick. So near real-time monitoring. So near real-time monitoring, what is this going to be used for? Well, near real-time monitoring, something's changed, and maybe I got alerted from my real-time monitoring situation. So something happened, and I need to identify exactly what happened, right? I also need some type of information like how everything is related in my infrastructure, right? So I need to know what servers are downstream from a router or switch that's having an issue. I need to understand when a specific router, or if a whole network is having an issue, or a specific section of my network is having an issue, how is that going to affect the rest of my business? I need to fully understand that, and hopefully these near real-time monitoring solutions give you some insight into what, if something goes wrong and you don't have any type of high availability in place, you want to point out those areas of your network that are going to suffer if something does happen. So hopefully these near real-time monitoring solutions give you insight to that. And let's go on to the next one. So flow data. I think we kind of talked about this enough here, but the flow data, really it's just all about confirming exactly that the network traffic is behaving the way you expect. That's all it is, right? So you want to be able to say, my application owners are happy with the way their application services are all working. Your users are all very happy with how quickly they're accessing the internet services or just different internal business resources. You want to make sure that everybody's satisfied, and flow data can give you insight into that, right? So let's go to the next one here. So config backup, right? Really, this one here is just, I need to store my config somewhere in case something bad happens. God forbid we have a disaster recovery situation. We want to be able to have a place where we can quickly restore our entire infrastructure as fast as we can. And then sometimes you just need to go searching through these configuration items for specific lines of config for auditing purposes. So you want the tool that you choose for this, you want to be able to have those features, right? So keep that in mind. Let's move on to the next one with logging here. And then logging, you really just need to be able to store massive amounts of information in a structured way. So these logs usually come in some type of structured format, hopefully JSON or the standard logging format. There's a bunch of tools nowadays that can help parse weird formatted logs and turn them into standardized information. But you need to store these logs, and you're going to have logs coming from every single device. And really what you need to be able to do is correlate them together. So there's tools out there that index all this information and they store common fields together. So an IP address, you might query your log server for an IP address, and you're going to get back not only the router information that's serving that network, you're going to get back the server's MAC address that's using that, or the interface MAC address, right? You're going to be able to get everything that this logging database knows about that IP. You're going to be able to retrieve that information, right? Let's go on to the last one here, your CMDB. And your CMDB, really, this is not only the two things that I have mentioned here, hardware maintenance, long-term planning, but even incident tracking, right? And change tracking, right? You want to be able to say, these devices are going to be down for a few hours because this person was conducting a change on this part of the infrastructure. Everybody gets alerted. Your real-time monitoring solutions are aware of the change as well. So that way when your NOC or your team that monitors those tools gets an alert, they don't need to be overwhelmed by maybe what looks like a network outage. They can reference your CMDB for a change. You want to be able to say, long-term, how much money do I have to spend on hardware within the next coming year, within the next coming 24 months? You want to be able to budget that out correctly. And your CMDB should be able to house that information that you need. These responsibilities, it's critical that you have just reliable information about the life of your infrastructure and also what versions you're running and things like that. It's super critical. So we've talked about the different silos of information that you're going to need access to. Now, In order to achieve network assurance, you're going to need to take a mixture of all that different information and be able to apply rules or queries that assert whether or not the way you expect your network to behave is actually behaving, right? So it's time to really just jump into IP Fabric, I think, and take a look at how our tool can help you true up some of your different silos of information and give you access to that data very quickly that you might need about your network infrastructure. Now, I think IP Fabric sits in the middle of a couple different tool sets. You might use us for a couple different tools, but we actually are constantly ever-changing database of information. So IP Fabric is going to always update based off of the most recent discovery of your network, right? I don't want to get too technical about how IP Fabric works. My other colleagues have definitely covered that information in other tech fabrics, but the important thing here is to know that the data inside of IP Fabric is always changing. So IP Fabric might act as a silo of information for other sources of truth to access. So let's dive into IP Fabric. Let's look at some information that's available to us and how we might apply some of the different data points available in IP Fabric to some of the different data silos or databases that we talked about. All right, so let's just quickly jump on into the platform here. Here I have IP Fabric in the top left of my screen. I have a couple different snapshots available here. Again, remember, our snapshots always represent a point in time. So I have some snapshots from in the beginning of the year, earlier this month, in January, and I also have some from this morning and a couple days ago, right? So what we're looking at here is the dashboard of IP Fabric, and this dashboard kind of gives us an overview of this health and a state of my network. And now this is a great example of what network assurance is, right? IP Fabric just takes a lot of data from the network infrastructure and allows you to create queryable rules and assert whether or not those rules are true, right? And if those rules are true, we're going to create some reporting. That's what you're seeing here. Now, let's dive into one of these tables, right? Let's just take a look at some of the information that's available. And let's stay simple. Let's just look at our devices. Let's look at our network infrastructure devices. And here you can see I have from this morning on the 20th, right? Let's flip actually to today, the 22nd, right? Recording today on the 22nd. This is this morning's snapshot. We can see all the different devices that IP Fabric discovered. We have some cloud environments. We have a private MPLS. We have a head office, some colo data centers, just different sites. And here, if I click on any of these devices, you can quickly see all the information available to you. All right. Now, how does this relate to what we talked about in the beginning of this video with all the different tools that are available out there? You might say, well, isn't this just another tool? I would say that the IP Fabric, this tool in particular, will help you solve most of the issues that you're going to have when it comes to data collection for all the other silos that we talked about, right? IP Fabric can do, to help you true up your CMDB by looking at what we just talked about here in the devices table, right? We tell you everything you need to know about this device, how it was accessed, its serial numbers here in the middle, the IP address used to log into it, its uptime, right? Everything that you might need to know about this information is available here in our platform. It's exportable over CSV. You can access this information with a Python SDK or over API calls as well, through a programmatic interface if needed. So the information you might need to true up your CMDB, it's all right here, right? Individual part numbers of your devices, every single interface in your network, right? Now, let's talk about IPAM, right? Your IP addresses in your network. How do you get that information and constantly ensure that it's up to date? Let's go take a peek at a table here in IP Fabric that can help you out, right? So I'm going to go to the technology section here, right? Going to go to addressing, and we're going to go to managed IP addresses. Now in this managed IP address table, I have every single device in my network, every single interface on each device, right? And you can see what IP address, the MAC address, and what network it's hosting. Even the VRF that's available, right? So when it comes to the different silos of data that you have and that we discussed earlier, IP Fabric helps you ensure that those silos or those tools that you're using for that are accurate and reflect what's actually deployed on the network, right? Now, I said IP Fabric's an ever-changing data set, right? So if you constantly rely on the data from IP Fabric, things are always going to change. You really should be able to, you really want to, I guess you could say, point out the discrepancies between what lives inside of your IPAM, right? What you think you have configured versus what actually is configured, right? Sometimes it's a difficult reality to face that your network might not be configured the way you intend it to be.
All right, so we looked at some of the different tables that can be used to true up our CMDB.
Let's go through a quick exercise of actually using the data inside of IP Fabric to maybe true up an external CMDB. So let's check this out. So we have our devices table here inside of IP Fabric. Here we have 418 devices total. Now, I'm going to bring up a pretty popular CMDB, one called ServiceNow, right? So I'm going to flip over to ServiceNow here, and I've already installed our IP Fabric app. Now, if I go over here and type in IP Fabric, you'll see there's a section here called IP Fabric Devices. This table here is going to be empty because I haven't populated it just yet. But if you head on over to our public documentation, you'll see exactly how and where this integration lives and some instructions on how to install it. So we get a command line utility, plus we also get an awesome ServiceNow application install. So make sure you go through this part of installing the application and then using the CLI tool to push these devices. So that's what we're going to quickly walk through. Let's start from the top. So IP Fabric applications installed. I have a table called devices inside of my ServiceNow instance underneath the IP Fabric application. We're going to take a look at the network gear table because this is where our source of truth lives for all the different networking gears. And here, this is the default networking gear table that comes with a developer instance of ServiceNow, right? What I want to do is actually pull up our console here and bring it over here in 1 second. And you'll see there's no devices, nothing from IP Fabric is currently here inside of ServiceNow. So the first thing I want to do is actually clear out this table. So if you're a developer, you might know about invoke, but don't worry about what I'm doing here. All I'm doing is just clearing out the ServiceNow table with some tools I created on the back end. So if you want to contribute, please reach out. We have some awesome tooling, right? So I went ahead and deleted all those devices. Going to refresh our CMDB table, and here we go. Starting blank slate. So let's clear this again, and now let's look at the documentation and just take a step by step, right? So the first thing we'll do is run IP Fabric Snow sync help. So let's go ahead and do that, right? And whoops, what we get here, let's clear that. Let's do IP Fabric -snow sync --help. And let's take a look at what gets outputted. So we only have one option here, so we can only run the command devices, right? So let's go ahead and run the command devices. So devices -help again. I'm going to keep on getting a feel for all the different available options to send out this data into IP Fabric. So by default, we're going to use that IP Fabric devices table. That's what's highlighted here. Great. The first thing we're going to want to do is probably run a dry run and just make sure that everything works, right? So that's awesome. Let's keep on scrolling down the documentation and just get through some of these examples real quick. So we went through sync devices help. You see that output's right here. Let's see this. So we actually want to run a diff of what's inside of ServiceNow, and let's do a dry run. So let's just copy this, right? Go ahead and paste it. You'll notice that caret towards the end got added over here. I'm just going to click on my cursor so you can see, and I'm going to delete that caret. So I'm just going to press enter. And we have a show diff and a dry run. So here we get outputted with some good information. We can see, oof, there's plenty of devices inside of our IP Fabric instance that are not inside of Snow, right, or ServiceNow. So we have plenty of things to update. So let's go ahead and update them, right? So let's go ahead and send all this information right into ServiceNow. So what I'm actually going to do is take off this dry run option, and we should get the same output, right?
410 devices. We can see that the dry run actually worked because we have 418 devices in there and 0 in IP fabric, and boom, looks like it's running. Looks like it ran already. Wow, super fast, right? So let's take a look at ServiceNow. I'm going to refresh our CMDB and see no devices here. And that's kind of expected, right? Because the devices haven't necessarily been transferred into here just yet. So let's go take a look at our IP Fabric application. Let's go take a look at that devices table, right? So here we can see all the devices from IP Fabric, like here we go, VNet Spoke 02. So if we grab this device and go over into IP Fabric and let's stick it in here, we can see we sent this device from IP Fabric into ServiceNow, ingested it, and we're going to take a look at the results here in a second. So let's see. So let's go see if it actually, we have state pending. That's where you can tell they actually haven't been shoved into the actual table just yet. So let's see. So it looks like finally got added, inserted, the states has changed. All right, so let's go back to that network gear table. Oops, excuse me. And here we go, right? So now we see all the different devices all chewed up from IP Fabric, right? So I just wanted to go through that quick exercise and show you guys just how easy it is to set this up. So we talked about in the very beginning how your CMDB is just one silo or one database of information for your network infrastructure. Now you might need a tool that goes out and does discovery and fetches all that information for what goes into your CMDB. And this exercise helps you understand exactly how easy it is to set some of these things up. Here at IP Fabric, our solutions architect team builds integrations like this. We have plenty of them available in our public documentation. So make sure you go check them out, right? And check out our integration section and see if any of these integrations are interested in you. Please feel free to reach out. You just saw a quick example of how easy it is to chew up some of the information in your different databases. Right.
So we just discussed a little bit about IP Fabric's dashboard and network assurance, and how IP Fabric, once it does a discovery, you're going to have this amazing dashboard of over 150 what we call intent checks that represent the network assurance and health and state of your environment. We also went over a quick example of ServiceNow and how you can sync up the Netgear table. So really good examples of how these different silos and these different environments all can be interactive and work with each other to ensure that the data inside of one database is either present or not present in the other database, and try to start figuring out why, what happened. Maybe an unauthorized change occurred and 2 or 3 devices disappeared, right? IP Fabric can show you that immediately and show you that, hey, yesterday your CMDB was this, but today it's this. And we don't know why, but let's start figuring it out and start integrating other sources of information to quickly automate and figure out what happened and why did it happen, right? Let's go through another example of how you can programmatically use the data inside of your configuration backup tool to do network assurance as well. We'll go through an example called PyNet check. And then we're also going to go through some examples of how you can use the PyNet check repo and how you can use your configuration backup database to perform network assurance checks against the STIG, whatever you want to refer to it as, compliancy checks. So the most recommended network checks from the US government. Let's take a look at this example. We'll quickly then take a look at some of the reporting that comes out of running these tests, and you can see how quick and easy it is to really have somebody on your team come up with some of these tests themselves. All right, so for this example, I think it's best to work a bit backwards, and let's just talk about what we're trying to do and how we're going to do it, right? So what we're doing here is we're looking at the DoD Cyber Exchange website, and we're looking at the SRG/STIG library compilations, right? So I've downloaded this already locally, and I've pulled it up, and it's not fun to look at, but let's go through it and try to pull out some of the best information that we can. And you can see, it doesn't look that great to look at. If you're on a Windows PC, you can download their proprietary viewer and actually view it there. But what I've done is actually pulled it out and stuck it into some comments
in our code here. So let's just review quickly what the rule is that we want to talk about. The first one, let's talk about how we're going to ensure that our network is following this rule set, right? So the first rule here, the title is just the Cisco router must be configured to limit the number of concurrent management sessions, right? So whatever your organization's defined for the amount of like line VTY sessions or the amount of HTTP connections if you have the server enabled, which allows you to connect right over HTTP to some of these devices and serve over an API. How many concurrent sessions are you going to allow to this device? Whatever your organization recommends. Ideally, it's related to limiting the risk of DDoS attack by just limiting the amount of connections you're exposing, right? So the example they give you is what some configuration is this bit right here. So for every line VTY, we want to make sure that the transport input is either set to none, right, or it's set to SSH, right? And we want to make sure that there's not more than 4 or 5, probably, right? And then we also want to make sure that the maximum concurrent sessions on your HTTP server are set to at least lower than 5, right? So the default is 5. And a couple notes here, this requirement's not applicable to FTP, SCP, stuff like that, right? So this is applicable to administrative sessions. So let's take a peek at this test right here. And what we're doing here is actually getting the device from IP Fabric. That's what this represents. But what you can see, what I really want to point out is just this assert statement right here. So this assert statement is after it's fetched the amount of line VTY sessions, if it's greater than 5, we're returning this string right here. So your IP HTTP max connections is configured, but it's greater than 5. So this is what we call a test. We're asserting if this is true or not true, right? And then same thing for the line VTYs. We're looking for, we want to make sure that SSH is in each line VTY configuration section, and then telnet is not, right? Or any is not, right? Hence the nots here. So this is how we can ensure that specific sections of our config are following that standard. And then we're going to get the number of line VTYs that are allowed to be configured. And then here we even left a comment for you to change it, right? So set your your security standard here. Then we're going to loop over each section, and we're going to make sure that the total sessions are not more than 5. Because if they are, right, that's a problem. We're going to report that and assert on it as well. Cool. So I don't want to spend too much time on code. I know it's not the greatest to look at. So let's go ahead and take a look at IP Fabric and see what are we actually going to pull from IP Fabric. So here are all my devices, right? You can see all the host names and all the serial numbers, all the configs that we've pulled, right? So IP Fabric serves as a configuration backup system as well. You might also have a tool that maybe Rancid's a popular one that pulls all your configs and sticks them into a Git repo. That's totally fine too. You can use that with the integration that we built here at IP Fabric. So we're going to actually look at the full configuration of each device, right? So let's open this config up here. And we're actually going to take a look at specific items in there, what we just talked about. But we can do this programmatically, right? Using what we call PyNetCheck. So let's take a look at the PyNetCheck repo real quick. Here we go, right here. This is on GitLab, publicly available. If you want to get started with it and you're familiar with Python and stuff like that, go ahead, follow the instructions. Super easy to get started, right? Well, let's go ahead and run PyNetCheck locally here. So let's go to my local instance here of PyNetCheck. And what we're going to do here is run PyNetCheck. And you can see it's already going to pop up with what the command is that we're going to run. So PyNetCheck. Let's run --help just to see what comes back, right? So PyNetCheck --help lets you know exactly all the different options. Now there's a bunch of options here. A lot of them are built in right to PyTest, right? Because this is wrapped around PyTest. If you don't have access to IP Fabric, you can go ahead and pass your configuration directory. So where a directory that has all your network configs. So you don't even need to have IP Fabric to run this. Pretty cool offer, right? So what I'm gonna do is run pynet check --tb, and that's a pytest flag for how verbose you want the output to be, and we don't want the output to be too verbose in this example. And then -m, and this is going to be called a marker, and I've specified those tests using a special marker. If you want to take a quick peek at that there is a mark right here for Stig or Cisco. So if you select Cisco, it's going to run these devices, and then if you're going to select Stig, it's also going to run these devices, or these tests, excuse me. So let's go ahead and run Stig. So add Stig as a mark. That's what the M flag stands for. So we only want to run specific tests. Let's just count how many tests we're actually going to run. So anything that says test counts as a test, right? So let's see here. So we have 1 test, 2 tests, 3 tests. Is that it? 4 tests. So we have 4 tests. Okay. So we have 4 tests that are going to run on each device here if I run this command. Right? So I'm going to press enter. And you can see it's reaching out to IP Fabric. It's grabbing the information. It collected a whole bunch of tests, 215 to be exact. It deselected almost 900 and it selected almost 1200. So excuse me, 1100. It looks like it's running a whole bunch of tests, and you can see a lot of our devices are failing. Right, so green dots represent a pass and a red F represents a fail. As you look through, you'll see some devices actually pass more than 1 test. Right, so we have that device passed more than 1 test. This device passed more than 1 test. We just got to wait for the results to see exactly what passed, what failed. Right, so let's give it a second. 75%, 90%. And almost done, and we can see, look, another device almost passed. So here we go. So we get this awesome output here, and I know what you're thinking, like, Chris, this output isn't that helpful. How do I understand, what really got affected? So what actually is really cool about what we've written here is it comes with this export of a HTML file, right? So this HTML file gets served just like a web page locally. So this HTML report file kind of allows you to view those tests individually, right? And actually see, what did we run? So we ran this test, we ran this file, right? So we ran the Stig test for a Cisco router. This was the name of the file from the library. We had 301 passes and then 819 failures, right? So let's go take a peek at each one of those. So here we go. I'm going to change this to show 50 entries each. We can see all the passes right here for that HTTP connections. Maybe if we filter. Here we go. So we had a couple. We had this device actually fail that HTTP max connections failure. So let's go find this device's config. All right, so let's go jump over to IP Fabric. Here in the hostname section, we're going to paste in that hostname that we found. We're going to pull the most recent config, right? Save it, open it. Let's see, so we're actually looking for that HTTP server connection string, right? So let's do Control F, let's do HTTP. Here we go, there it is, right? So we can actually see that this device indeed had, over the amount of recommended connections, right? Even though the server's not enabled, if somebody accidentally enabled that server, you're going to be allowing 7 connections to it, which could be a problem. It's not, it's not the worst thing in the world, but it is a problem, right? I hope this example helped you understand how you can integrate with different data points to perform network assurance, right? In this example, we just covered how you can use your config backup data to perform network assurance using Python and a pynet check framework that we developed here at IP Fabric. But there's nothing stopping you from coming and trying out IP Fabric for yourself and writing some of these intent checks yourself right into IP Fabric, right? So we could have taken that example a step further and show you how to do it here inside of IP Fabric, right? And doing something similar with our intent checks, as you can tell. These are just if statements on some of the data points. So if this information was kind of intrigued you and you were like, I wonder how I could do this on my network, please reach out and let's get the conversation started.
All right, guys, that's everything for this episode of Tech Fabric. I hope you enjoyed it. I hope you enjoyed the 2 examples of network assurance that we gave you using different silos of information, right? So not only did we try to true up some of the data that was in your CMDB, try to give you an example of how you could do custom network assurance writing some custom tests using Python and a tool that we built here at IP Fabric called PyNet Check. Until next time, guys, it's been always a pleasure, and catch you guys in a few months on the next episode of Tech Fabric.